Hi, welcome back to another lesson on the Computing Guy YouTube channel. Today we're going to be looking at binary addition and shifts. So previously we've looked at binary numbers and converting between binary and decimal numbers. And now we're going to expand our knowledge and see how we can actually add these numbers. So just like we did previously, we're going to first focus on decimal numbers and how we actually add in decimal numbers. So when we're adding in decimal numbers, all we simply do is we take the first number and add the second number to it to obtain our result. However, the process in adding two binary numbers is slightly different, purely because we only have two values in each column. There are 5 simple rules for us to adhere to when we're adding out binary numbers, and these rules are 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1. Now, up until this point, pretty straightforward, just like you'll see in decimal numbers, it's pretty easy. Now, students tend to find the two rules that confuse them. So 1 plus 1 is equal to 0, and then we carry 1 over to the next column. Now, obviously, some instances, students might write the number 2, which is understandable. And the next rule, which is 1 plus 1 is equal to 1, carry the 1, is an instance where you have 1 plus 1 as your two numbers, but then you've carried 1 on from the previous column. So you now have got 1 plus 1 plus the carry, and that gives us 1, carry the next one over. So those are the simple rules that we need to follow. And we're now going to look at some examples of this and how we can actually utilize binary addition. So I've got 2 examples here that we're going to be looking at, and we're going to be doing these on screen for you to see. So I've got a very simple one here on the left. Okay, we've got 1 0 plus 1 1. And how I personally learned about all of this was very simple. I'll just look at the rules, and then when I look at the rules, I'll then use that for each column. So 0 plus 1, if you look at the rules, is 1. So very simple. I'm just going to write a 1 here. Now 1 plus 1 is equal to 0, carry the 1. So 1 plus 1 is equal to 0. And we're carrying 1 over. Obviously, we've got blanks here, so we can just say they're zeros. And your answer will now be 1 0 1. So that's a very simple example, very straightforward, not too complicated. We've only got 2 values in each number. Now we're going to expand this slightly and use a bit more of a difficult scenario to help us. So we've got 0 plus 1 is equal to 1. And we've got 1 plus 1, which is 0, carry the 1. Not very good, 0 there. And then we've got 1 plus 0 plus 0, that gives us 1. We've got 1 plus 1, which is 0. We're carrying the 1 over, which gives us 1 plus 1 plus 1, which gives us 1, carry the 1 over again. 1 plus 1 is equal to 0. And we're carrying 1 over. Now we're actually going to hit something that's quite interesting, which I'll be explaining on the next slide, but we're going to do this anyway. So 1 plus 0 plus 1 is equal to 0. And carrying the 1 over. Obviously, we've got zeros there. And now we've got an extra value that we've got. And we've actually ended up with 9 values, which is very interesting because it's something we're going to be looking at later on. What we need to know is from that previous example, we actually had something called an overflow error. Now, the reason why we call this an overflow error is because we have to assume we only have 8 bits worth of memory, hence why we've got an 8-bit value for our binary number. Now, if we've gone on to the 9th bit, we've got an overflow of memory. We're not going to have enough memory. This is going to cause problems for the computer. So this is referred to as an overflow error. And this is a result of calculations which require more bits or place values than the available range. Now, I'm going to run another example for you so that you're able to see exactly what happens in an overflow error. So we've got 1 plus 1. We're going to do 0, carry the 1. Okay, 0, carry the 1. So we can see what's going to happen because the numbers are just repeating themselves. Okay. So there we go. 0 and another 1. Carry the 1, 0. Another 1. Carry the 1, 0. Another 1. Carry the 1, 0. another 1, carry the 1, 0. And then finally, we've got 1 here. And that gives us a new column and value. Now, if we remember, 8 bits gives us 8 bits gives us 128 as the last value. Now, using our knowledge, we always double the value. So 64 became 128 up here. Now we're going to have a new column, which is 2, 5, 6. So you can see we've created a new column. This is the overflow error, okay? And this is something that we want to avoid because it means we've run out of memory or we've fallen out the memory range. But in your exam, you might be given a question where you end up having an overflow error and you're asked, so what was the problem with that answer? And you need to be able to justify your answer using this definition here. So that's binary addition with overflow errors. Nice and straightforward. You stick to your rules and you follow them along the way. We are now going to move on to multiplication. And how do we multiply in binary? Now, this is very simple. We just make shifts to the left. And we'd always be multiplying by the binary numbers themselves. So a shift to the left by 1 place will multiply by 2 places by 4, and by 3 places by 8, and so on and so forth. But I'm going to show you a nice and straightforward example here so we can visually see what's going on. So here I've got my pen. So this value here is just the 2 ones, and 1 plus 2 we know gives us 3. So I'm just going to write 3 up here. Now I'm going to shift everything to the left. So the 2 moves to 4, the 1 comes to 2, and we're going to put a 0 in the new empty value. And 4 plus 2 gives us 6. Now I'm going to shift it one more time. So we've got 8 and 4. The new positions get zeros because there's no values there. And 8 plus 4 gives us 12. So as we can see, 3 has doubled. So we times it by 2, that gave us 6. And then we've times 6 by 2, which gives us 12, which is the same thing as 3 times by 4. So that is an example of multiplication and how we can use shifts to multiply our numbers. Now, the next thing is division. Now, of course, division is the opposite of multiplication, right? So we're going to probably be doing the opposite thing. We're going to be shifting, okay? And we're going to be shifting to the right. And each time we shift to the right, we divide by 2, and then a further 2 and a further 2. So one shift will give us a division of 2. 2 shifts will be giving us a division of 4, and 3 shifts will be giving us a division of 8. So we're now going to be looking at an example. We've got a binary number here, 11010. That gives us the value of 26. Because 16 plus 8 gives us 24, plus the 2 will give us 26. We're now going to shift everything along. So the 16 goes to 8, the 8 goes to 4, the 0 for 4 will go to 2, and the 1 that was in the 2 column will go here. So if we add these numbers up, 8 plus 4 will give us 12, and 12 plus 1 will give us 13. So we can see we've now got this value. And if we shift it one more time, the 4 will be taking the value of what 8 was, because 8's moved 1 space to the right. The value in the 4 column will go to 2, and the value in the 2 column will go to 1, and that's 0. And that's giving us 6. Because obviously we've divided by 2, and there's no decimal numbers in binary. So we've rounded down, and there we go. So that's an example of shifting to the right in binary, which gives us division. Thank you for tuning in to today's lesson on binary addition and shifting in. I hope it's been helpful for you. Please like, comment, share, and subscribe. I will see you at the next video.